Okay.
All right. So he said something. He just reminded me something. Right now, the for males, are you there? Of I forgot to say it. For males, the number of red blood cells for males is what? 5.2 million. Are you there? 5 billion, right? For males, so 200 what? Thousand. Plus or minus what? 300,000. Right? Cubic per cubic what? Millimeter of blood. For males, are you there? For females, it is what? 4,700,000 plus or minus what? 300, right? Per cubic what? Millimeter of what? Blood. Please take note of this. Are you there? Take note of this. Essentials will tell you that it is what? It is 5 million for males and 4.5 million per cubic millimeter for what? Females, right? Yes. This one is for guiding. Are you there? Are you there? All right, so can we continue? So let's talk about how red blood cell is produced. The process of production of what? Red blood cell. Are you there? The process of what? Production of what? Red blood cell. So the first thing we'll talk about is the site. Are you there? We'll talk about what? The site of production. Right? Now, in fetus, right? In fetus, the site of production is usually in what? 3 stages. Are you there? The site of production occurs in 3 what? Stages. The first stage is called the mesoblastic stage. What did I say?
Mesoblastic.
It is called the what? Mesoblastic what? Stage. Mesoblastic stage. Are you there? Now, in mesoblastic stage, red blood cell, that is in fetus, right? I'm talking for with respect to the fetus, right? Are you there? Right. Now, during fetal life, right, red blood cells are produced in what? 3 stages. The first stage is what? The mesoblastic what? Stage. Now, during the mesoblastic stage, red blood cells are produced from what? The mesenchyme of the yolk sac. Are you there? They are produced from what? The mesenchyme of the what? Yolk sac. And this usually occurs during the first what? Trimester. It occurs during the what? First trimester of gestation. Are you there? That is during the first 2 to 3 months of gestation. Are you there? Red blood cells are produced from what? The mesenchyme of what? The yolk sac. Right? The second stage is referred to as what? The hepatic stage. The hepatic what? Stage. Can you see that? Can you see that thing?
Gestation.
Can you see that? What do you say? First trimester, that is the first 3 months of intrauterine life. Do you understand? First trimester of gestation. Gestation, that is pregnancy.
Prince, you will help me with your notes.
What did I have to
Bosque. So this one don't have post. What? This one don't have post. Due to his live stream, yes.
Don't come in to this vicinity with Okada. Right? If they catch you, you pay how much? You know the amount you pay, and you go to the bank and pay. Are you there? Yes, yes. I was begging him, but he refused. All right, so let's continue. So the second stage is what? Hepatic what stage? Right here. So during the second trimester, or from the 3rd month, right? From the 3rd month of intrauterine life, right? Red blood cell is produced by the liver, right? It is produced by what? The liver. Are you there?
Yes, sir.
And also by other, predominantly by the liver, but it's also produced by the spleen. Are you there? And the lymphoid what? Lymphoid organs or tissues. Are you there? But predominantly by the what? Liver. And that is why we call it the hepatic what? Stage. The third stage is the myeloid what? Myeloid stage. The third stage is what? The myeloid what? Stage. Are you there?
Yes, sir.
Now, during this stage, red blood cell is produced by what? By the red bone marrow, and also by the liver. Are you there? But predominantly by what? The red bone marrow, and that's why we call it the myeloid stage. Are you there? That's why it is called what?
Myeloid.
The myeloid stage. Are you there? Now in newborn, now right, in newborn, right? Adolescent and adult, right?
Okay.
Now from 0, right? From 0 to 5 years. Are you there? From 0 to 5 years, red blood cell is produced by all the bones. Are you there?
Yes, sir.
It is produced by what? All bones. All bones produces what? Red blood cell. Now, from 5 years up to 20 years, right? From 5 years up to 20 years, red blood cell is produced by membranous bones. What did I say? It is produced by membranous bones and all the long bones, and all the membranous bones. Are you there? Are you there? From 5 to 20 years, it is produced by what? All the membranous bones and all the what? Long bones. Are you there? Now, then, from 20 years and above, as an individual becomes older, right? The marrow, there is deposition of fats in the marrow of what? The long what? Bones. Are you there? Are you there? It becomes yellowish. and then the hemopoietic function begins to what? Dwindle. So therefore, during that particular stage, that period of life, that is from 20 years and above, 20 years and above, from 20 years and above, red blood cell is produced basically by membranous bones. When I'm talking about membranous bones, I'm talking about flat bones like your skull bones, right? Flat bones like your what? Iliac bones. Are you there? Your iliac what? Bones. Your skull bones. Your iliac what? Bones. Your vertebrae, right? Your vertebrae, right? Your clavicle. All those ones are what? Membranous what? Bones. And also, you should know that red blood cell is also produced by the shafts. The shafts of what? The ends of what? Long bones. The ends of long bones and all membranous what? Bones. That is from 20 years and above. Do you get it? Do you get it? You don't get it? Now, let me repeat myself again. In fetal life, right? We have 3 sites, right? Of red blood cell production. 3 stages. The first stages is what? The mesoplastic stage. During this stage, red blood cell is produced what? By what? By the mesenchyme of what? Yolk sac. The second one is the hepatic stage. In the hepatic stage, red blood cell is produced by what? By the liver and by the spleen and what? Lymphoid tissues. Are you there? Then the 3rd stage is called what? The myeloid stage. In the myeloid stage, red blood cell is produced by what? The bone marrow. Are you there? Now, in newborn, right? In newborn, that is from 0 to 5 years, red blood cell is produced by all what? Bones. That is by both membranous bones and long what? Bones. When I'm talking about long bones, I'm talking about what? Your humerus, right? Your femur, your tibia, your fibula. They are all what? Long bones. When I'm talking about membranous bones, I'm talking about the flat bones, like your skull bones, right? The scapula, yes. The clavicle, right? Your iliac bones. They are what? Membranous what? Bones. So, but from 0 to 5 years, red blood cell is produced by all the bones. From 5 years and above, that is from 5 years to 20 years, red blood cell is produced by what? All the membranous bones and all the long bones, right? Now, as an individual becomes older, right, the bone marrow begins to lose its hemopoietic what? Function. Do you understand? Due to the deposition of what? Fat. Are you there? In other words, the marrow becomes yellowish in nature and loses its hemopoietic what? Function. And in that case, it is only the ends of the long bones that produces what? Red blood cell and all membranous what? Bones. So basically, red blood cell is produced by membranous bones and the ends of what? Long bones. Is that difficult to understand? No. It's not difficult to understand. Now, that will now bring us to the fate of red blood cell. The fate of red blood cell. The fate. F-A-T-E. Fate of red blood cell. Fate of red blood cell. The fate of what? Red blood cell. Now, thank you. The lifespan of red blood cell is 120 what? Days. Red blood cell has a lifespan of 100 and what? 20 what? Days. So after 120 days, what will happen? The red blood cell will become what? Old. And what do we call old red blood cell? We call them senile red blood cell. Senile what? Red blood cell. Senile aeropsis, senile erythrocytes. They become old. Are you there? And senile means old. Are you there? They become what? Senile. right? Now, senile red blood cells are actually fragile in nature. Are you there? Their cell membrane are what? Fragile in what? Nature. Now, when they try to pass through capillaries, right? Because of their fragility, what will happen? They will begin to what? Rupture. Are you there? And like I told you, the diameter of red blood cell is quite smaller than the diameter of what? Capillaries, particularly the splenic what? Capillary. When I say splenic capillary, I'm talking about the capillaries in the spleen. Are you there? So when red blood cell, younger red blood cells can easily pass through these capillaries with ease, right? But when senile red blood cells attempt to pass through the splenic capillaries, what will happen? They will begin to what? Rupture. And when they rupture, what will happen? They begin to release their what? Hemoglobin. Do you understand? And because red blood cells are you there? Because red blood cells are predominantly ruptured, senile red blood cells are predominantly ruptured in the spleen is referred to as what? The graveyard of what? Of red blood cell. Do you get it? Now, when red blood cell rupture, like I told you, they release their what? Hemoglobin. Right? And of course, hemoglobin contains what? It contains hem and globin. Are you there?
Yes, sir.
Hem contains what? Iron, ferrous iron, and what? And porphyrin or protoporphyrin. Are you there? Now, the iron, right? The iron will bind with a beta globulin called apoferritin. When it binds with apoferritin, it becomes what? Ferritin. So it is stored as ferritin in the reticuloendothelial system. Are you there? It is stored. I should come again. Hemoglobin is broken down to hem and globin. Are you there? Hemoglobin is broken down to what? Hem and globin. Hem is breaking down to what? Iron, ferrous iron, and what? And protoporphyrin, right? Proto what? Porphyrin. Are you there? Now, the globin, right? Returns back to what? The protein what? Depot. It goes back to the protein depot, right? But then the iron binds with a beta globulin called what? Apoferritin. Apoferritin is a beta globulin. Are you there? When it binds with apoferritin, it becomes what? It is stored, right? In the reticuloendothelial system as what? Ferritin. As ferritin. Ferritin. In the reticuloendothelial system. Reticuloendothelial system. So it is stored in the reticuloendothelial system as what? Ferritin. That is to say that it is stored in the liver, right? The liver cells, we call them copper cells. They are stored there. Are you there? Right? They are stored there. And then the iron becomes what? Ferritin. Are you there? The iron becomes what? Ferritin. Then what happens to the protoporphyrin or porphyrin? What happens to the porphyrin? Porphyrin is converted to what? Biliverdin. Biliverdin is further converted to bilirubin, right? And bilirubin is stored in the gallbladder as what? Bile. It forms what? Bile. Are you there?
Yes, sir. I come again.
Hey.
I come again with parents.
Are you doing the video?
Yes.
Are you doing the video? So after now, you gotta watch the video.
I do later.
He said, you look for that data now.
What did you say? Studying the same the
iron. All right. So that's the faith. That's the faith of red blood cell. That's the faith. When I say faith, that is how it ends. When they say faith, your faith, right? Someone will say, "What is my faith? What is my end?" You understand? That's the faith of what? The red blood cell. Right? It is broken down to what? It is broken down to what? It is when it is ruptured, it releases hemoglobin. Right? Right? Hemoglobin is broken down to what? Hem and globin. Right? Hem is broken down to what? Iron and porphyrin or protoporphyrin. Right? Iron. Right? Iron binds with apoferritin and becomes ferritin. Right? Are you there? Globin goes towards the protein. Globin is an amino acid, right? So it goes to the protein depot, right? Then which other thing? Porphyrin. Porphyrin is converted towards biliverdin, which is eventually converted towards bilirubin, and is eventually stored where? In the gallbladder as what bile. Are you there? So that's that. So let's talk about the functions. The functions of red blood cell. The functions of red blood cell. The number one function of red blood cell is that red blood cell is responsible for the transport of oxygen. What did I say? It is responsible for the transport of what? Oxygen. It binds with oxygen, right, in a reaction that is called oxygenation. Oxygenation. This reaction is actually a reversible what? Reaction. Are you there? We call it oxygenation. And what does it form? It forms hemoglobin. Hemoglobin. Oxy what? Hemoglobin. Are you there? Are you there? So it binds with what? Oxygen. It carries oxygen from the alveoli of the lungs to the various what? Tissues. Also, we can say that the second function is that it can transport what? Carbon dioxide. It carries carbon dioxide from the tissues, right? It carries carbon dioxide from the tissues to where? To the lungs. Are you there? It carries carbon dioxide from the tissues to the lungs. So it binds with carbon dioxide and forms what? Carb hemoglobin. Carb hemoglobin. Carb hemoglobin. Carb hemoglobin. Are you there? The third function of red blood cell is that red blood cell has a buffer what? Action. It has what? A buffer what? Action. You know what buffer means? Yes. You know what buffer action means? Yes. It has the ability to remove what? Hydrogen. Right? Hydrogen from blood. So that blood will not become what? Acidic. Do you understand? Are you there? And of course you know how, I think I've explained how it does that. I've explained how it what? Does that. You know the tissues. The red blood cell has what we call carbonic anhydrase. Are you there? It has an enzyme called what? Carbonic what? Anhydrase. So when tissues releases carbon dioxide will what? Combine with what? Water. Right? It combines with water in the plasma to form what? Carbonic acid. Do you understand? Right? To form what? Carbonic acid. And of course, you know that carbonic acid is not good for the body. Right? So the carbonic anhydrase in red blood cell will convert carbonic acid to what? Hydrogen and bicarbonate what? Ion. Are you there? Hydrogen and bicarbonate what? Ion. Right? Bicarbonate ion will be transported to the lungs. Right? That is, the carbon dioxide is transported to the lungs as bicarbonate what? Ion. Are you there? Whereas hydrogen will combine with oxygen to form what? Water. Is it also? To form what? Water. Do you understand? All right. So let's continue. Now let's talk about erythropoiesis. 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 Yeah? No, it's not spelling. Erythropoiesis. Erythropoiesis is a process of formation of red blood cell. Are you there? Erythropoiesis is the process of formation of what? Of red blood cell. Erythropoiesis is the process of formation of what? Red blood cell. Then there is another term called hemopoiesis. Hemopoiesis is the general term, right? Hemopoiesis is the general what term. When we say hemopoiesis, we are talking about the formation of what? Blood cells. When we say erythropoiesis, the formation of what? Red blood cell. When we say leukopoiesis, the formation of what? White blood what cell. Thrombopoiesis, if there's a word like that, the formation of what? Platelets. Are you there? So erythropoiesis is the process of formation of what? Of red blood cell. Are you there? There is what we call primitive what? Stem cells. Red blood cells are usually formed from what we call primitive what? Stem cells. Stem cells. Stem cells. You can call it primitive stem what? Cells. Are you there? They are formed from what? Primitive what? Stem cells. Now these stem cells are called hemopoietic. They are called pluripotent. 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 Right? Hemopoietic. Poietic stem cell. Are you there?
Yes, sir.
They are called pluripotent what? Hemopoietic what? Stem cells. Right? But usually, there are some stem cells that are not, they don't have the capacity, right?
Yes, sir.
They don't have the capacity or the tendency to form blood cells. They are just there. So we call those ones uncommitted. 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 Pluripotent. Hemopoietic what? Stem cells. We call them what? Uncommitted, pluripotent what? Hemopoietic stem cells. Now when these uncommitted pluripotent hemopoietic stem cells become committed or have the capacity or tendency to form a particular what type of blood cell, it is referred to as what? Committed pluripotent hemopoietic stem cell. Are you there? So from uncommitted pluripotent hemopoietic stem cells, we now have what? Committed pluripotent hemopoietic what? Stem cells. Now, committed pluripotent hemopoietic stem cells can actually form two bloodlines of what? Cells. The first one is called lymphoid stem cell. The second one is called myeloid stem cell. Okay, let me draw it so that you understand it, because the way I don't like the way you are looking at my face. I don't like the way you are looking at my face. So we have uncommitted, pluripotent, hemopoietic what? Stem what? Cell. Right? Uncommitted, pluripotent, hemopoietic stem cell will give rise to what? Committed, right? Pluripotent, hemopoietic what? Stem cell. Committed, pluripotent, hemopoietic stem cell has a tendency to form the various types of what? Blood cells. Right? which are what? We have the lymphoid stem cell, and then we have the what? Myeloid stem what? Cell. Are you there? The lymphoid stem cell and the myeloid what? Stem cell. The myeloid stem cell, the lymphoid stem cell, gives rise to what we call lymphoblasts. What did I say? It gives rise to what? Lymphoblasts. The lymphoblasts eventually form what? Lymphocytes. Lymphocytes. Are you there? It forms what? Lymphocytes. And of course, the lymphoblasts can also give rise to what we call natural killer cells as well, right? But basically, lymphocytes. And of course, you know that we have two types of lymphocytes. When we talk about immunity, you see it. We have the T lymphocytes and the what? B lymphocytes. Are you there? The T lymphocyte is responsible for what? Cellular immunity. The B lymphocyte is responsible for what? Humoral what? Immunity. Are you there? But we'll come to that. But just know that the lymphoid stem cell gives rise to what? Lymphoblast that eventually form what? Lymphocytes. The myeloid stem cell, right? The myeloid stem cell is also referred to as colony-forming blastocytes. Are you there?
Yes, sir.
It is also called what? The colony what? Forming what? Blastocyte. What is a blastocyte? A blastocyte is a cell that can give rise to what? Colonies of what? Cells. Are you there?
Yes, sir.
The reason why they call it colony forming blastocyte is because when you culture the cell, it can give rise to what? Colonies of what? Cells.
Yes.
Right? That's why they call it colony forming what? Blastocyte. Are you there?
Yes, sir.
Right? You can let me write it on that. That's it. In bracket. Colony what? Forming blastocytes. Are you there? Now, this colony forming blastocytes can give rise to what? It can form colony forming units. Colony forming units, erythrocytes. Are you there?
Yes, sir.
It can form what? Colony forming units, erythrocytes. It can also form colony forming units, granulocytes and monocytes. And can also form colony forming unit what? Megakaryocytes. Right? The colony forming units, megakaryocytes, can give rise to what? Thrombocytes. Thrombocytes that forms what? Platelets. Are you there? Colony forming units, granulocytes and monocytes, forms what? It forms neutrophils, eosinophils, and basophils. Right? And then also forms what? Monocytes. Also forms monocytes. Colony forming units, granulocytes and monocytes, forms neutrophils, eosinophils, basophils, and then the monocyte forms what? This M forms what? Monocytes. M is monocytes. This one, granulocytes and monocytes. Granulocytes and monocytes. This is colony forming units, granulocytes and monocytes. It forms neutrophils, eosinophils, what? Basophils and monocytes. You want me to go to this step, right? Colony forming units, granulocytes and monocytes will give rise to what? Monoblasts. Monoblasts will form monocytes. Granulocytes, right, will give rise to what? Myelocytes or myeloblasts, right? Myeloblasts will give rise to what? Neutrophil myelocytes. Eosinophil myelocytes. Basophil myelocytes, right? Neutrophil myelocyte will give rise to what? Neutrophil metamyelocytes that will eventually form neutrophil. But I don't want to go into that step so that you not be confused. You don't need that.
this guy.
So, but just know that colony forming units, granulocyte and monocyte will give rise to what? Neutrophil, eosinophil, basophil, and then monocyte. Right? Then colony forming units, erythrocytes, will form what? Erythrocytes. It will form what? Erythrocytes. Are you there? Now, the whole of this is known as hemopoiesis. Right? It is called, the whole of this is hemopoiesis. So we are not interested in all of this. Right?
Why not?
Listen to me. We are not interested in all of this. What we are interested is this. So this is the erythropoiesis that we are talking about. But I just wanted to tell you how erythropoiesis comes about. Are you there? So erythrocytes, which are the red blood cell, is from where? It's from what? Colony forming unit what? Erythrocytes. Which is what? Which comes from where? From myeloid what? Stem cell. That is coming from where? From committed pluripotent hemopoietic stem cell. Coming from where? All committed pluripotent stem cell. Coming from where? From the primitive what? Stem cell. Do you get it? Don't forget it too. All right. So now, this committed, calm down. This committed pluripotent, colony forming units, erythrocyte, right? Gives rise to the various stages of red blood cell. Are you there? It gives rise to what? The various stages. It gives rise to the various stages of red blood cells. And what are the stages? First of all, it gives rise to what we call the pro-erythroblast. Pro-erythroblast. I will draw the diagram and I will explain it. Right? Yes, now, this one now, colony forming units, erythroblast is like this. Let's say this is it. Are you there? Then it has a large what? Nucleus. Are you there? Yes, sir. And the nucleus has a very visible what? Nucleoli. Two or more what? Nucleoli. This is called colony forming unit what? Erythrocytes. Now, colony forming unit erythrocyte will now give rise to what? It will give rise to what? Pro-erythroblast. Right? Pro-erythroblast is also large. Right? It's also large. Right? Has a large nucleus. Are you there? It has a large nucleus and also has what? Nucleoli. The nucleus is almost covering the what? The entirety of what? The cytoplasm. Are you there? And at this stage, it has some what? Ribosome. Are you there? It has some ribosomes, and because of those ribosomes, it makes it to what? To stain with what? Methylene blue. So under the microscope it is blue, right? In color. Do we have blue marker here? Do you have blue marker? I didn't come with my markers. So it is what? Blue in nature. Is cytoplasm. Cytoplasm is blue. Are you there? Because of ribosomes. Are you there? that are present here. Now, pro-erythroblasts will further divide, right, and give rise to what we call early nomoblasts. Are you there? Early nomoblasts. Early nomoblasts. Right. Early what? Nomoblasts. Now, early nomoblasts is like this. Now, pro-erythroblast has a diameter, right, of about 20 watts micron. Are you there? This one has a diameter of about what? 20 watts micron. Has a large nucleus that contains what? Nuclei and some ribosomic what? Materials. Are you there? Now, early nomoblast has a diameter of about, let's say, 18, right? 18 micron, right? And of course, in early nomoblasts, there is condensation, right, of the chromatin what? Material. There is condensation of the chromatin what? Material. That's to say the nucleus becomes smaller, right? It becomes condensed. Are you there? Right? And then it stains because of the ribosomic what? Materials. It stains what? With methylene what? Dye. So it is what? Blue in nature. Are you there? It is blue in nature. There is disappearance of what? The dye. Are you there? But the nucleus becomes condensed. The chromatin material becomes what? Condensed. And the size becomes what? Smaller. Right? It moves from 20 micron to what? 18 micron. Right? Now, because it stains with methylene dye, right? Because it stains with methylene dye, so it is what? Blue in color. Are you there? And because of that, we can also call it what? Basophilic erythroblast. We can also call it what? Basophilic erythroblast. Are you there? So it can also be called what? Basophilic what? Erythroblast. Now, the next stage is intermediate. Intermediate nomoblast. Now, in intermediate nomoblast, you will observe that the cell becomes smaller, right? It drops down to, let's say, 15 watts micron. Are you there? The chromatin material becomes more condensed, right? And then small amount of small amount of hemoglobin begins to appear, right? Small amount of hemoglobin begins to what? Appear, right? And then of course there is still what? Ribosomic what? Material that makes it to be blue in color. So it is both blue and what? Red in color. So some parts is red, some parts is blue. Are you there? Blue, red. Are you there? So, in this case, hemoglobin begins to what? Appear. So, it stays both red and what? Blue. Right? So, this particular stage is called what? Polychromatophilic or polychromatophilic what? Erythroblast. Polychromatophil, or you can call it polychromatic erythroblast. Are you there? Polychromatic erythroblast. The next stage is called late nomoblast. It is called what? Late nomoblast. Late nomoblast. In this stage, right, you observe that the cell becomes smaller, right? It is, let's say, to 12 what? Micron. Are you there? And then there is the nucleus becomes very small, very, very small. Are you there?
Yes, sir.
It becomes very, very what? Small. And nucleus now. Are you there? The nucleus becomes extremely what? Small. And at that point, we call it ink spot nucleus. Are you there? We call it ink spot what? Nucleus. Very tiny. Are you there? It's very what? Tiny. And then, of course, it eventually leaves the cell. Right? That process is called pycnosis. Pycnosis leaves the cell at that point, at this stage. Right? So it is very small and has lots of what? Hemoglobin. Lots of what? Hemoglobin. Are you there? So this stage is called autochromatic erythroblast. It is called what? Autochromatic erythroblast. Are you sleeping?
No.
It is called autochromatic what? Erythroblast. Can you see? You can see. It's not my fault now. It's my fault that you cannot see. It's not my fault, sorry. Can you carry it here? But I'll bring it down.
The thing will just fall. Just leave it like that. It's interesting.
Yes, that's where it starts. It starts there, yes. Hemoglobin starts from there. But it's very, very infinitesimal that it doesn't appear. You understand? Actually, she's right. Hemoglobin production actually starts from this early normoblast, but it's very small that it doesn't really appear. Right? Are you there? Are you there? But here you begin to see it becomes very obvious at this point, and becomes very, very obvious at this point. Are you there? Right? So here, the nucleus becomes very tiny. Call it inch spot what? Nucleus. Can you now see? You can't see? There's nothing I can do for you.
Sir, can we take pictures?
You can't take it. If you take it to the top, the ball will fall. Can you?
Yes, sir.
Oh, you will hold it.
No. Yeah, this side. It will fall. I can't.
Just stand on top of the.
It will fall. It will fall on these people. Sit down, sit down. And I cannot write. Yeah, would I? All right, this is better. All right. So after left normoblast, the next stage is called reticulocyte. Reticulocyte. Reticulocyte.
Stage joke for next time.
Now in this stage, right, all the materials, there is complete disintegration of the nuclear material, the chromatin materials, the ribosomic what materials and all that, and they now begin to form a meshwork. Are you there? A meshwork, right? A meshwork like this, right? Reticular what? They become reticular in nature. Reticular, right? In nature.
What's another word for reticular? Another word for reticular.
Another word for reticular? No, it's reticulocyte. Do you have another word?
No.
Reticulocytes. Are you there?
Just leave it like that.
That has lots of what? Hemoglobin. Lots of hemoglobin. Now, at this stage, red blood cell is around, let's say, almost 8 micron, or thereabout. Are you there? About 8 to 10 micron. 8 to 10 micron.
So we say this one.
Are you there? So at this stage now, the red blood cell is close to being mature. Are you there? But it is not yet mature. And it is not yet, it's at this point, it is still in the bone marrow, right? It does not enter the capillaries. Are you there? Are you there? So, you know, the process of red blood cell takes about 7 days. The process of production of red blood cell takes about what? 7 days. So, the reticulocytes appear around the what? The 5th day, right? So, after 2 days, the reticulocytes now become what? Matured what? Erythrocytes. They now become what? Matured erythrocytes. Are you there? That is smaller in nature. And of course, the diameter at this point is 7.2 micron. You remember? Yeah. It's now 7.2, yes?
Why is the erythrocyte still spherical?
Spherical at this point. Wait, bring. Where is it? It becomes smaller. You are right. It becomes what? Smaller and becomes biconcave what? In nature. So it becomes matured at this point and has lots of what? Hemoglobin. Right? And on the 7th day, it is released into what? The capillaries. Right? And it enters the what? The bloodstream and begin to perform its what? Function. Are you there? So that's the process of what? Erythropoiesis. That's the process of what? Erythropoiesis. Is it hard? It is not hard. You must know it. Eh?
Yes, sir.
You must know. You sit in the exam. Oh. Eh? You sit in the exam. So you understand the process now. From uncommitted pluripotent stem cells to committed what? Pluripotent what? Stem cells. Like I said, committed pluripotent stem cells will give rise to what? 2 what? Stem cells. 2 lines of what? Stem cells, which are what? The lymphoid stem cells and what? The myeloid stem cells, which is also known as what? The colony what forming what? Blastocytes. Right? Now, the colony forming blastocytes will give rise to the various colony forming cells, unit cells, which are the colony forming unit what? Erythrocytes, colony forming unit granulocytes and megakaryocytes and what? Neurocytes, and colony forming what? Megakaryocytes. Are you there? Now we are not interested in the colony forming unit megakaryocytes and the colony forming unit what? Granulocyte and what? Monocyte. What we are interested in what? The colony forming unit what? Erythrocytes. Now the colony forming unit erythrocytes will eventually give rise to what? It will give rise to what? Pro-erythroblast. From pro-erythroblast we now have what? Erythroblast. Erythroblast is also called what? It is also called what? Basophilic what? Erythroblast. From there we now have what? Intermediate what? Nomoblast, which is also known as what? Polychromatophil what? Erythroblast. Or you can call it polychromatic what? Erythroblast. From polychromatic erythroblast we now have what? The late what? Nomoblast, which is also known as what? The autochromatic what? Erythroblast. The autochromatic erythroblast will give rise to what? Reticulocytes. And the reticulocyte will eventually give rise to the matured what? Erythrocytes. Clap out for yourself.
Exam, you will write it.
We are learning. So, if I said this in exam, you pass it, Abi?
Yes, sir. I hope this is not your exam. I said it too.
All right.
I hope you said it.
Now, there are some factors. Are you there? There are some factors that are responsible for the production of red blood cells. right? These factors are divided into what? Three. Right? The first factor is known as general factor. The second factor is known as maturation factor. The third factors are factors that are responsible for the production or formation of hemoglobin. The first one is known as what? General factor. The second one is called what? Maturation factor. The third factor is called what? Factors that are responsible for what? For the formation of what? Hemoglobin. So let's talk about the first factor, right? Now, in the first factor, which is the general factor, there are some factors that are implicated in erythropoiesis. The first one is, number one is erythropoietin. Are you there? Erythropoietin. Under general factors, erythropoietin. Are you there?
Wait.
The first one is erythropoietin. Are you there?
Yes, sir.
Now, erythropoietin, right? Erythropoietin is a glycoprotein that is produced by the peritubular capillaries of the what? The kidneys. Right? It is a glycoprotein that is produced by the peritubular capillaries. It is a glycoprotein produced by the peritubular capillaries of what? The kidneys. Peritubular. Peritubular capillaries. Right? Peritubular capillaries of what? The kidney. Are you there? Now, what is the stimulant for erythropoietin production? Who can tell me? What actually stimulates the production of erythropoietin? What stimulates it? Hypoxia. Are you there? When there is low, right? Low oxygen what? Content. Right? When there is low oxygen what? Content. When the body lacks oxygen. Hypoxia. Right? Low oxygen content. When the concentration of oxygen in the body is low, in the tissues is low, right? It will send signals to what? The kidney. And the kidney will begin to produce what? Erythropoietin. Right? And what will happen? Erythropoietin will enter the blood, right? And go here to the bone marrow and begin to stimulate the bone marrow to produce what? Colony forming what? Unit what? Erythrocytes, right? Which will eventually produce this down to erythrocytes. Are you there?
Yes, sir.
Are you there? So you can see how important the erythropoietin is, right? And 80% of the erythropoietin that is implicated in erythropoiesis is produced by the kidney, right? 20% is produced by the liver. Are you there? Right? So if your kidney is damaged, then what will happen? You become anemic. Right? You become what? Anemic. The second factor, the second general factor is tyrosine. Number 2 is tyrosine. Are you there? It's called what? Tyrosine. Tyrosine is a general what? Hormone that is meant for what? The general metabolic activities of the body, right? It also helps in erythrocyte what? Production. Are you there? Tyrosine helps in the production of erythrocytes. Are you there? Even interleukins. Interleukins are also implicated. Are you there? Interleukins are implicated in erythropoiesis. Interleukins. Particularly interleukin 3. Interleukin 3, right? Interleukin 6 and interleukin what? 11. Are you there? Interleukin 3, interleukin 6, and interleukin what? 11. Interleukin, they are cytokines. They are what? They are what? Cytokines. If you don't call it cytokine, you call it interleukins. They are also implicated in what? Erythropoiesis. Are you there? Now let's go to the next factor, which is maturation factor. Under maturation factor, number one, we have cyanocobalamin. Cyanocobalamin. If you don't call it cyanocobalamin, what do you call it? You call it vitamin what? Vitamin what? B12. Vitamin B what? 12. Are you there? I write vitamin B12. Cyanocobalamin. Vitamin B12 is very, very important in erythropoiesis because it helps in what? In DNA what? Synthesis. Are you there? It is implicated in DNA what? Synthesis. Right? And vitamin B12, vitamin B12, right, is usually absorbed in the what? In the small intestine. How? How? Who can tell me? Who can tell me? Sorry, it is absorbed in the stomach. It is absorbed in the stomach. How? Who can tell me how? Now, in the stomach, right, especially around, there are some cells that we call parietal cells, right? Right? There are some cells that we call what? Parietal cells of the gastric glands, the gastric mucosa, right? Now, these cells, these parietal cells, are responsible for the production of what we call intrinsic factor, right? If you don't call it intrinsic factor, you call it intrinsic factor of Castle, right? What do? They bind with vitamin what? B12, right? They bind with vitamin B12 and what? And carry them into what? Into the enterocytes. From the enterocytes, it goes down to where? It goes down to where? Look at me. It goes down to where? The bone marrow. And aids in what? In erythropoiesis. Are you there? Are you there? So vitamin B12 is one. The second one is intrinsic factor. Intrinsic factor. Intrinsic factor binds with what? Vitamin what? B12. Without intrinsic factor, vitamin B12 cannot be what? Absorbed. So in a situation where the mucosa, the parietal cells are destroyed, for instance, if somebody has peptic ulcer, right? If somebody has peptic ulcer, right? You know that the parietal cells will be what? Destroyed. So in that case, what will happen? Vitamin B2, intrinsic factors will not be produced, and so the individual will not be able to absorb what? Vitamin what? B12. And in that case, what will happen? The person will come down with anemia. And what do we call that type of anemia? We call it what? Pernicious anemia. We call it what? Pernicious anemia. Right? Now another one is folic acid. Another factor, maturation factor, is folic acid. Folic acid or folates. Folic acid is implicated in what? DNA what? Synthesis. So without folic acid, without vitamin B12, without intrinsic factor, what will happen? There will be what we call maturation factor failure. Right? There will be maturation what? Failure. Red blood cells will not be properly what? Matured. And so red blood cells will become what? What will happen? They will become megaloblasts. Okay. Right? They will be very big. Right? They will be what? Very big. We call it megaloblast. In fact, we say they will be megaloblastic. They will be what? Very big. And megaloblasts are usually what? Fragile. When they pass through capillaries, what happens? They rupture easily. Are you there? Are you there? They rupture what? Easily. Now, the third factors are factors that are responsible for what? The formation of what? Hemoglobin. Factors that are responsible for the formation of what? Hemoglobin. These factors are number one, amino acids. Are you there? Number one, amino acids. Number two is ferrous iron. Are you there? Ferrous iron. Ferrous iron. Ferrous iron. Number two is ferrous iron. Number three is what? Who can tell me? Copper. Copper. Copper is responsible for what? For the absorption of iron. Copper is responsible for the absorption of what? Iron. Are you there? Iron is responsible for the formation of what? Hem. Right? Copper is responsible for the absorption of what? Iron. Then the next one is called nickel and cobalt. Cobalt. C-O-B-A-L-T. Nickel and cobalt. They are responsible for the utilization of what? Iron. They are responsible for the utilization of what? Iron. Are you there?
Yes, sir.
All right. Now, let us talk about the variations of RBCs. Variations, right? In the size, the number, and the shape of RBCs. The first one we talk about is the variation in terms of what? Number, right? Under variations, right? We normally have variations
Red blood cell.
erythrocytes or red blood cells. Under variations, right? Under number, we have what we call polycythemia. Are you there? We have what we call what? Polycythemia. And polycythemia is usually an increase in the number of what? Red blood cells. Are you there? An increase in the number of what? Red blood cells. And we normally have two types. We have physiological polycythemia and we have pathological polycythemia. Physiological polycythemia is normal. It is physiologic. Are you there? It is an increase in the number of red blood cells. Do you understand? Above 7 million, about 7 million and above, right? Are you there? But then the increase is usually temporary and nominal, right? In physiological polycythemia, the increase in the number of red blood cells is what? Physiologic is temporary and what? Nominal. Now, a good example is age, right? Is age. In newborn, the number of red blood cells is more in newborn compared to adults. In newborn, we have about 10 millions of red blood cells, right? Per cubic what? Millimeter. Are you there? But as the individual begins to grow, right, it begins to what? Reduce. When the individual becomes an adolescent, becomes what? Let's say 8 million or thereabouts, right? But when the person becomes an adult, right? When the person becomes an adult, what happens? It comes down to what? 5.2 million, plus or minus 300,000. Are you there? For males, are you there? Then for females, it is what? 4.7. Plus or minus 300,000 per cubic what? Millimeters. Right? So you can see that there is a difference in age. Are you there? Then the next one is sex. Males have more than females. Right? Like I told you, males, for males it is about what? 5.7 plus or minus 300, 5.2 plus or minus 300 what? Thousand. Female is what? 4.7 plus or minus 300,000 per cubic what? Millimeter. Are you there? Yeah. Then another thing that increases red blood cell is what we call altitude. People that live in high altitude, right? That is people that live at let's say people that live at high altitude that is above 10 feet, right? 10 feet and above mean sea level, right? They usually have what? Polycythemia, an increase in what? The number of what? Red blood cell, right? Why? The reason is because above that level, the oxygen concentration is what? Low. Do you understand? So because the oxygen concentration is low, what does it do? It brings about what? Hypoxia. and hypoxia stimulus muscular what? Exercise. During muscular exercise, what happens? There is contraction of the spleen, right? And of course, you know that the spleen is a reservoir of what? Red blood cell. So when the spleen is contracted, what happens? It releases more what? Red blood cell. Another one is during meals, after meals, right? After meals, when once you finish eating, the number of red blood cell will what? Increase. Another one is during emotional condition. During emotional condition, right? Your number of red blood cell what? Increases, right? Which is due to what? Sympathetic what? Stimulation. Are you there? Now, there are also some factors that bring about temporary decrease in red blood cell. Are you there? Right? The first one is during pregnancy. During pregnancy, there is a decrease in the number of red blood cells. Why? During pregnancy, the ECF volume increases. Are you there? The ECF volume increases. ECF volume increases during pregnancy, and because of that, it affects the blood what? Volume. It also increases the blood volume. And when there is an increase in blood volume, what will happen? It will result in what? Hemo what? Dilution. So therefore, the red blood cell, the number of red blood cells will what? Decrease. The second thing is during sleep. During what? Sleep. When you are sleeping, number of red blood cells what? Decreases. Are you there? Are you there? It also what? Decreases during sleep. Are you there? Are you there? So pregnancy, during sleep, and then low barometric pressure. Low barometric what? Pressure. That is when you are inside the water, down inside the water, below sea level. Are you there? The oxygen tension increases, and because the oxygen tension increases, it results in decrease in red blood cell production. Are you there? Now, there is also variation in size. What did I say? There is variation in what? Size. Now, if you'd agree with me, venous blood, right? Venous blood usually have larger erythrocytes. The erythrocytes in the veins are larger than the erythrocytes in the what? Artery. It is physiological. Are you there? It is what? Physiological. That is to say it is normal. Right. But then, pathologically, when there is an increase in the size of red blood cell, right? It is called what? What do we call it? Macrocytes. Are you there? Macrocytes. It is called what? Macrocytes. A good example is what? During megaloblastic anemia. Are you there? During megaloblastic anemia, the cells becomes what? Larger in size. Are you there? The next one is microcytes. Microcytes. That is to say that the cells are what? Smaller in nature. Are you there? A good example is during what? Iron deficiency anemia. During iron deficiency anemia, the cells tend to be what? Smaller. Then there is another one. The third one is what we call anisocytosis. Anisocytosis. When the red blood cells are not uniform in shape, we call it what? Aniso what? Cytosis. Aniso. Aniso. A-N-I-C-Y. Aniso. Aniso. Cytosis. Are you there?
Yes, sir.
All right. Then we also have variations in structure. What did I say? Variations in what? Structure. Now, there is what we call crenation, right? When you put red blood cell in hypertonic solution, what will happen? It will shrink. Is it also? So we call that crenation. Are you there? Then there is what we call elliptocytosis. Elliptocytosis is a situation where red blood cells tend to have an elliptical what? Shape, spherical or globular what? Shape. Are you there? In that, when you put red blood cell in hypotonic solution, they tend to be what? Globular in nature. Are you there? Then we have sickle cell, right? Sickle cell or crescentic shape. Sickle cells are crescentic in nature. Their shape is what? Are crescentic in nature. Are you there? Then which other one do we have? We have poikilocytosis. 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 Right? Where red blood cells are irregular in shape. We call it what? Poikilocytosis. Are you there? Then we have serocytosis. I think we have mentioned that one. Serocytosis. When the red blood cells are spherical in nature, they are called what? Serocytosis. Are you there? In terms of the nature of red blood cell, right? Or structure. In terms of structure, we have what we call punctuate. Number one, we have what we call punctuate basophilism. Punctuate basophilism. Right? In punctuate basophilism, there is a fragment of red blood cell around the periphery of the cell. A fragment of red blood cell, right? Or in fact, red blood cell appears striated in nature, right? And this striated nature, this striation appears around the periphery of the cell. Are you there? Then there's what we call, there's another one that is called we call it Jolly Howell Jolly body. Howell Jolly bodies. Howell Jolly bodies. Howell Jolly bodies. Where you have fragments of what? Fragments of basophilic materials, right? In the cell. Fragments of basophilic materials in the cell. Are you there? Then there's one that is called what? Goblet ring. Goblet ring. Where you have a ring of basophilic materials around the what? The periphery of the cell. Are you there? All right. Now let's talk about hemoglobin. Let's talk about hemoglobin. We don't have time again. We are supposed to talk about hemoglobin. We talk about anemia, and then we talk about jaundice. These three things. Next class.
Yes, sir.
Okay.
What do you like goblet for?
Goblet, not goblet. Sorry, goblet.
Ring.
Goblet.
Goblet for, sir.
Ring. Okay, and pathological. I didn't mention the pathological.
No, sir.
Why didn't you remind me? Why didn't you remind me to talk about the pathological? Okay, for the pathological polycythemia, we have what we call primary and secondary polycythemia. The primary and secondary polycythemia. The primary polycythemia is also known as polycythemia vera. Polycythemia what? Vera. Now, a polycythemia vera, there is what is called, there is a hereditary aberration, right? A hereditary aberration of the hemoblastic cell line. Are you there? There is a hereditary aberration of the hemoblastic cell line, and this appears in the form of what? Malignancy of the bone marrow, right? Which produces is like cancer, which produces more and more what? Red blood cell, which is above 40 millions per cubic millimeter of blood. And it also affects the white blood cells. As the red blood cells are being produced, white blood cells will also double and triple. White blood cell is about 4,000 to 7,000 cubic per cubic millimeter. But in this case, they now become what? 24,000. Are you there? So that's what we call polycythemia what? Vera. Right? Then
I feel like normal Vera, like Veronica.
you are not serious. Then secondary polycythemia is associated with other diseases like let's say emphysema, difficulty in breathing, right? Obstructive what they call congestive heart disease. Ayesa disease. Ayesa disease is when there is hypertrophy, right? Hypertrophy of what? Of the right what? Ventricle, right?
Yes, sir.
Hypertrophy of the right what? Ventricle, right? It brings about obstruction of blood what? Flow and causes what? Polycythemia. Are you there? All right. So now let's talk about hemoglobin. Hemoglobin, you know, is the red pigment of blood. Is it of red blood cell? Is it also? And it has a molecular weight. I just said it now, that it is associated with other diseases. Ayesa disease, I've mentioned it. You are not listening. All right, so the next thing we'll talk about is hemoglobin. Hemoglobin is the red pigment, right? The red pigment of what? Of the red blood cell, right? It has a molecular weight of 68,000, right? I will just be brief because we don't have time again. It has a molecular weight of what? 68,000. And what is the function of hemoglobin? Number one, its function is to what? It transports what? Oxygen from the alveoli to where? To the tissue. Number two, it carries carbon dioxide from the tissues to where? To the lungs. Number three, it acts as a buffer. Are you there? Number three is that it acts as a what? Buffer. Do you understand? There's one property of blood that I did not mention, right? That one function of blood that I didn't mention. Red blood cell, I didn't mention. Red blood cell also helps in blood group determination. Hope you are aware. It helps in blood group determination. Why? Because it contains what we call agglutinogen, the A agglutinogen, the B agglutinogen, and the resource factor. They are all present in the cell membrane of what? Red blood cell, and helps in what? Blood group determination. That is by the way. So now, talking about hemoglobin. Right. Now, how is hemoglobin? Okay, what's the number of hemoglobin in a typical male and female? Right? For male, it is 15 what? Grams, milligrams. Female, it is what? No, male it is 14, right? No, sorry. Male it is 15, right? It is 15. Female it is 14. Are you there? For female it is 14. Male it is 15. Female it is what? 14. Are you there? And how is hemoglobin formed? Who can tell me? Can you tell me? Or I should tell you? I should tell you. Yeah. Hemoglobin is formed, right? From hemoglobin is formed when succinyl-CoA, succinyl, right? Succinyl. Okay, let me draw right here on the board. Do you have another class? Yes. Which class do you have?
Anatomy.
Huh? Anatomy. And your lecturer is around? Yes. Are you sure? Is the lecturer coming here? Yes. He's coming here. You are going there or here? Yeah. Okay, when he comes, I will leave now. I should go. Let me finish. See. Hello. Let me finish this topic. I said I will talk about white blood cell. You're not serious, so. Okay. Succinyl. CoA. Are you there? Right? And this is gotten from Krebs cycle, right? Succinyl-CoA will combine with what? Glycine. Are you there? It will combine with glycine to form what? Pyrrole. Pyrrole. Are you there? It will combine with glycine to form pyrrole. Now, four pyrrole will come together to form the pyrrole what? Ring. Right? No, sorry, 4 pyrrole will come together to form what we call protoporphyrin. 9. Are you there? It will form what? Protoporphyrin what? 9. Right? Now, protoporphyrin will combine protoporphyrin 9 will combine with ferrous iron, right? Ferrous iron to form what? Hem. So can you see it now? Right? Hem will combine with what? With what? With globin to form what? Hemoglobin. To form polyhemoglobin chain. Are you there? To form polyhemoglobin what chain? Now, this polyhemoglobin chain could be what? Alpha what chain or beta what chain? Are you there? Right? So usually hemoglobin contains 4 what? Polyhemoglobin what chain? Are you there? Hemoglobin contains what? 4 polyhemoglobin what chain? And in this 4 polyhemoglobin chain, 2 are alpha chains. Are you there? 2 are usually what? Alpha chains. Now, for adult hemoglobin, right? For adults hemoglobin, we have what? 2 alpha chain, 2 of this what? Alpha chain, and 2 what? Beta what? Chain. For adult what? Hemoglobin. For fetal hemoglobin, we have 2 alpha chain and 2 what? Gamma what? Chain. Are you there? Adult hemoglobin is 2 alpha chain, 2 beta chain, right? Fetal hemoglobin is 2 alpha chain and 2 what? Gamma what? Chain. Are you there? Are you there? Adult hemoglobin is 2 alpha chain, 2 beta chain. The fetal hemoglobin is what? 2 alpha chain and 2 beta what? Chain.
Gamma.
2 gamma chain, sorry.
What's the difference?
There's difference. This is gamma, this is alpha. Right? But this one has more affinity. This one has more affinity for what? Oxygen than this one. Are you there? Fetal hemoglobin has more affinity for oxygen than what? Adult hemoglobin. Right? Then there's what we call hemoglobin abnormalities. Right? Now, the 2 abnormalities of hemoglobin are what? Hemoglobinopathies. Number 1 is hemoglobinopathies, and number 2 are hemoglobin disorders that are associated. Okay, number 2 is Polycythemia and other related hemoglobin disorders. Number one, that is hemoglobin disorders. Hemoglobin disorders. Number 1 is what? Hemoglobinopathies. Should I spell it? Yes, hey! Hemoglobinopathies. 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 Yes. Number 1 is hemoglobinopathy. Number 2 is what? Thalassemia. And other related what? Hemoglobin what? Disorders. Abnormalities of hemoglobin. Now, when we talk about hemoglobinopathies, right? We are talking about disorders of hemoglobin. Number one is hemoglobin S. Hemoglobin what? S. Are you there? Hemoglobin what? S. Hemoglobin S is known as sickle cell. Is it also? Now, in sickle cell, the cell appears to be what? Sickle or crescentic in shape. Are you there? And usually the hemoglobin usually precipitates, right? There is precipitation of the hemoglobin within the red blood cell. And because of that precipitation, when red blood cell passes through capillaries, what happens? It ruptures the what? The red blood cell. Are you there? That is why you see sickle cell patients are always having crisis. Are you aware? Are you aware? The second one is hemoglobin C. Hemoglobin C. Are you there? This occurs in hemoglobin C disease, right? It occurs in hemoglobin C disease. Hemoglobin C occurs in hemoglobin C disease or disorder, right? And it is characterized by mild hemolytic anemia. It is characterized by mild hemolytic anemia and splenomegaly. Splenomegaly. Should I spell it? Splenomegaly. Splenomegaly. Right? Splenomegaly. Mild hemolytic anemia. Mild hemolytic. Hemolytic. Megaly. Then we also have, this is what did I mention? Hemoglobin C. We also have hemoglobin E. Right? Hemoglobin E occurs in hemoglobin E disorders or diseases, which is also characterized by what? Hemolytic what? Anemia and splenomegaly. Then we have hemoglobin M, right? Hemoglobin M, which occurs in blue baby syndrome. It occurs in blue baby what? Syndrome. Then we have syndrome. Then we have thalassemia. Thalassemia. The second one is thalassemia, right? We have talked about the what? The hemoglobinopathies. Let's talk about thalassemia and other related what? Disorders. Now for thalassemia, in thalassemia, there is either an increase, decrease, right? Thalassemia. In thalassemia, there is either an increase, thalassemia, look at it on the board. There is either an increase, decrease, right? Or an irregular number of the polypeptide chains to be either the alpha chain or the beta chain. Do you understand? If there is an increase or decrease or an irregularity in the number of the alpha chain, we call it alpha thalassemia. If there is an increase or decrease or an irregularity in the number of the beta chain, we call it the beta what? Thalassemia. And this particular disorder usually occur mostly in people that are from Thailand. Are you there? Thailand. Or there is what we call Mediterranean, right? Mediterranean.
Central America.
Right?
Yes, sir.
It occurs in people that are from this region. Are you there? That is why sometimes it is called Mediterranean what? Disorder. It is also called Mediterranean what? Disorder. Are you there? Now, there is what we call hemoglobin derivatives. Hemoglobin what? Derivatives. The first one is what? Carboxy hemoglobin. Carboxy what? Hemoglobin. In carboxy hemoglobin, carbon monoxide binds what with hemoglobin. The next one is what? Net hemoglobin. Net hemoglobin. Net hemoglobin. Net. The first one will produce carboxy hemoglobin. Yes. Carboxy what? Hemoglobin. The second one is net hemoglobin. Right? A net hemoglobin. The ion that binds with hemoglobin is usually in the ferric state rather than the ferrous what state. You know, the ion that binds with hemoglobin is usually ferrous in nature, but in this case it is what? Ferric in nature, right? And when it is ferric, it produces what? Met hemoglobin. The third one is sulf hemoglobin. Sulf hemoglobin. A sulf hemoglobin, right? Sulf hemoglobin. Hemoglobin binds with certain drugs. sulfonamide, right? It binds to certain drugs, like what? Sulfonamide. Are you there? All right. The next thing we shall talk about is iron metabolism. Iron, are you tired? We are not even started. We have not started. You people see, the people that are complaining are people that came late. Is it not so? See, people that look at those people that came late, they are the ones complaining. Me that I've been talking for 2 hours plus now, I'm not complaining. You that just came nah, you are complaining. See, that one is going.
We have not eaten.
All right. When next I come, we'll talk about iron metabolism, and then we'll talk about anemia. Then we'll talk about jaundice. When we talk about all those, then we are done with red blood cell. We'll now move to white blood cell and then immunity. All right. Have a nice day.
Anybody else not to come here now?
Are you serious?